Welcome to this demonstration of fuzzing command line utilities using CLIFuzzer. CLIFuzzer is a tool that grammar fuzzes CLI binaries by constructing their invocation grammar. It works on utilities that use standard library functions such as getup or getuplong to pass their invocations. For today's demonstration, we'll use our custom implementation of the utility called utility ls called myls as a target binary. myls contains about 10 short options which can be used to trigger or activate some particular code segments within myls. So if we invoke myls without any options normally or in the purpose of fuzzing, we see that the coverage achieved is quite low. It's about 29% of the statements and about 33% of the branches. So we will use CLIFuzzer to fuzz myls using its options after constructing a grammar that expresses these options for the purpose of invocations of myls. So CLIFuzzer exposes quite a few functionalities, including extracting just the options of the binary, extracting the grammar in the form of JSON of the binary, fuzzing the binary, and finally extracting the coverage achieved from a binary. I'll demonstrate each of these one by one. First, we start by by showing how CLIFuzzer extracts the options from myls. We will note down this options in a file called myls.options. Reading myls.options shows us that CLIFuzzer has successfully extracted all the 10 short options from myls. Next, we extract the grammar from myls. Internally, this also extracts the options. But the end result is a fully formed invocation grammar expressed in JSON syntax. Reading this file, we observe that the invocation of myls has been properly expressed here. Now we proceed to fuzzing myls using CLIFuzzer. We specify that we want to fuzz it 100 times. Using the grammar, we just extracted. And we want to log the output in a file called myls.out. And this log pass is a option that also logs the passing invocations. Typically, without this option, CLIFuzzer would only log those invocations that resulted in some sort of abnormal behavior. We call it for 100 times, and we observe that the grammar CLIFuzzer invokes the CLIFuzzer constructs the invocation from the grammar very quickly, and it is able to invoke and run the fuzzing very quickly. So now we'll look at the log file, and we see that this particular invocation of 100 times did not result in any exception, crashes, or unresolved behavior from myls. If there were any, they would have been noted down here, just like how passing results are noted down here. So we see that the first invocation was this, and the result was all right, and so on until 100 times. So now we want to check what is the coverage achieved by CLIFuzzer. This will subsume the one invocation we did for myls. So we can observe the overall coverage achieved. We can do this normally using the gcov command line function, or we can do this using the CLIFuzzer as well. So I'll demonstrate both. We use CLIFuzzer to get the coverage, and we want that in myls.c for myls. So if we normally run this using the command line utility gcov, we see that my fuzzing this has led to a higher coverage, quite a significant difference. Now it's 78, almost 79% of the statements as opposed to 29% earlier, and almost 90% of the branches as opposed to 33% earlier. And if we read the coverage achieved by myls, we see that this matches the observed coverage here. Lines coverage is almost it's the same, so is branch coverage and other information. That concludes our demonstration of CLIFuzzer. Thank you for watching.